Welcome back. Let's talk about linear functions in slope-intercept form. And just a quick review, we just finished talking about direct variation. And when we finished direct variation, we talked a little bit about how you can look at slope-intercept or the slope of a line as it relates to direct variation. So let's continue that thinking. And in this section, we're going to talk a little bit about linear functions and slope-intercept form. So let's first talk a little bit about slope. Now the slope of a line is going to be the ratio between the vertical change and the horizontal change. Now, anytime that we talk during this lesson about a line, we're not talking about a vertical line. So not talking about a vertical line. So anytime we talk about anything here, when we talk about slope of a line, we're talking about a slope of a non-vertical line. So the slope is going to be the ratio of the vertical change to the horizontal change between the 2 points. So we can calculate slope. There's a way to do that. So slope is, here's the vertical change, designated by this line here, up and down, and then the horizontal change. That's that ratio we're talking about. Now over here we have 2 points. We're going to designate this x2 and y2, x1 and y1 for the purposes of how we calculate slope. So the way that we calculate slope is that we look at that vertical change, which we call the rise, and we look at that horizontal change, which we call the run. So slope we often refer to as rise over run. So that rise over run is going to be the change in my vertical values. So it's going to be y2 minus y1. When I say y2, I'm going to designate this as 1, for example. So 1, 5. Let's say that's the first set of points, and then 2, 6, for example, just as an example. So when I say y2, that's y2. When I say y1, that value is y1. Now, so calculating the slope, we're going to say that's the change for y2 minus y1 over x2 minus x1. So we say y sub 2 minus y sub 1 over or divided by x sub 2 minus x sub 1. Now, x cannot be equal to 0. All right, so really quickly, rise over run, rise over 1. So one of the ways is to calculate it, and a bit later we're going to talk about how we can also look at the graph and designate the slope that way. All right, let's look at finding the slope of a line, and I'm going to give us 2 points here. So here's our 2 points, -3, 7, and -2, 4. So let's find the slope of the line that passes through these points. So step number 1, we're going to write out the point slope form. So it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Always write the equation first. All right, now y sub 2 is 4 minus y sub 1, which is 7. 2, 1. 4 minus 7 over -2 minus -3. All right, so that equals what? Step number 3. 4 minus 7 is correct, -3. -2 minus -3, so that's really -2 plus 3. So that's 1. So we have our slope of this line at -3 over 1. So we can say the slope of this line that passes through those 2 points is -3 over 1, or we can also call that -3. All right, let's try another one. All right, let's find the slope of a line that passes through 3, 1, and negative 4, 1. All right, I'm not going to write out 1, 2, and 3. Now, I was writing that out to make sure that you always follow those correct steps. So, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 equal, so 1 minus 1 over negative 4 plus 3 equal negative 4 minus negative 3. All right, so then we've got equal 0 over negative 7, which is equal to 0. So the slope of that line is 0 over negative 7, or 0. So what I want you to do is to make sure that that denominator cannot equal 0, right, at all. If it equals 0, then we're going to call that slope undefined. So let's do an example where we have an undefined slope and we still take it through the rigors of making sure that we use the point-slope form to get at our slope. All right, so we've got 7, negative 3, and 7, 1. All right, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, we've got 1 minus negative 3 over 7 minus 7 equals 0. And then 1 plus 3 is 4. So we can't have that. We don't do division by 0. Division by 0 is undefined. So the slope of that line that passes through those 2 points is undefined. So always remember to do all of the math in all the steps, right? Follow the steps, always starting with the point-slope formula. Now let's look at slope of a line as a summary of what we've been talking about. So there are 4 different ways that we can look at slope. If you see a line, for example, that passes through, or it rises from left to right, and I'm going to do this. So passes from left to right, goes this direction, right? Left to right goes that direction. That is called a positive slope. Okay, I'm going to put left to right. Now, if you have a line that falls from left to right, here it is, it's falling from left to right, then that's going to be a negative slope. That's going from left to right, negative slope. Now, if we have a horizontal line, right, from left to right, right to left, we have a horizontal line, then it has a 0 slope. 0 slope. Whereas if I have a vertical line up and down in both directions, then this is an undefined slope. Okay, we got rises from left to right, that is a positive slope. Falls from right to left, that's a negative slope. Horizontal line, that's a 0 slope. And a vertical line has an undefined slope. So, having known that, if we have a function and that function has a graph, which is a line. So if we have a function whose graph is a line, that's called a linear function. Now, this may be some review for you, especially if you had Algebra 1. So you can represent a linear function with a linear equation. Now, a linear equation is going to look something like this. Y equal 6x minus 4. This is an example of a linear equation. Now, A solution of that linear equation is going to be any ordered pair that makes it true. So any ordered pair that makes that equation true. So let's take a look. So a special form of a linear equation is called slope-intercept form. And let's talk about what that might mean. This is just a special form of a linear equation. And we just talked about that, but let's dig into that, what that might mean. So an intercept is going to be a point where a line crosses an axis. So we have an x-axis, we have a y-axis here. So the y-intercept then is going to be the point at which the line crosses the y-axis. Right there. See here, it's crossing the y-axis. That point right there is called the y-intercept. Whereas the x-intercept is where that point crosses the x-axis. So it's going to be where that point crosses the x-axis. And of course, we're talking about a non-horizontal line, because if you're talking about a horizontal line, you're not going to have an x-intercept. So then let's look at slope-intercept form. So slope-intercept form of an equation of a line looks like this. Y equal mx plus b. Y equals mx plus b. Now, each of these have a meaning. So m is our slope. And b is going to be our y-intercept. And that's important because it can tell us quite a few things if we can get our equation into slope-intercept form. So let's look at an example and write a linear equation and put it into our slope-intercept form. All right, so what if we're going to write an equation of a line, and I'm going to give us a couple of pieces of information here. So what is the equation of this line? So what is the equation? Now remember, the equation of slope-intercept form is going to be y equal mx plus b, where m is the slope and b is the y-intercept. So what is the equation of this line if m equal 1/5 and the y-intercept is at 0, -3. That's the point, coordinate. Well, so we can say y equal, we have a slope here, 1/5 x minus 3. You're correct. So our y-intercept, so y equal mx plus b, however, we would say plus -3, so we can change it to y equal 1/5 x minus 3. Now, let's take a look at what that graph looks like then, and then determine what our equation is from that graph. Okay, so we have an equation of a line that we figured out, and it passes through a couple of points, but let's get our equation out and ready here. So we've got y equals 1/5 x minus 3. All right, so if I tag my lines here, -1, -2, -3, -4, 1, 2, 3, 4, and then -1, -2, -3, -4, etc. 1, 2, 3, 4. So these are going to be hashed over there. All right, so I know that this line passes through -3 because that is the y-intercept. So I'm going to get my dot there, my coordinate point there, 0, -3. Now that I also know that my slope is 1/5, right? A ratio of 1/5. So I'm going to go up 1 over 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. And then I'm going to go up one more. 1, 2, 3, 4, 5. Because we were talking a little bit, we'll be talking a little bit about those intercepts, right? So I got a y-intercept here and an x-intercept. So that's what the graph of that line is at y equal 1/5 x minus 3. Now, let's find an equation of a line if I give you the slope of 6 and you have an intercept, a y-intercept at 0, 5. So y-intercept is at 0, 5. So what is the slope, what is the equation of this line if we've got a slope of 6 and a y-intercept at 0, 5? So it's going to be right about there. So we can say y equals 6x plus 5. We've got our y value there. So y equals 6x plus 5. So if we look at the equation of that line, then we have a slope, 6 over 1, and then we've got a y-intercept, so we can connect two of our dots, and we're going to simply go up 1, 2, 3, 4, 5, 6, and over 1. And when I do that, well, we're going to have a line that goes through there just like that. All right, so we've got an equation given the slope and given the y-intercept as well. So now let's take a look at writing equations in slope-intercept form. Given an equation, and then once we get it in slope-intercept form, we can easily then tell what the y-intercept and the slope are. And once we know those, we can simply get them into a graph once we do that. So let's start out with an equation 5x minus 4y equals 16. So we want to get it in slope-intercept form, right? Which is y equal mx plus b, where that m represents the slope and that b represents the y-intercept. So to begin to do that, we've got to begin to isolate that y. So what do we do to begin to do that? We've got to subtract 5x from both sides. So I've got 5x minus 5x minus 4y equal minus 5x plus 16. All right, so starting to take shape here. So those go away. That leaves me negative 4y equal negative 5x plus 16. All right, how can I get that y by itself? Well, I can divide both sides by negative 4. That leaves me, when these go away, that leaves my y over here equal 5/4 x. And then 16 divided by negative 4 is negative 4. All right, I got it there. So now I just need to identify what my slope is. So my slope is 5/4, or up 5/4, right? Rise over run. And my y-intercept is what? It's negative 4, so 0, negative 4. It's going to cross that y-axis at negative 4. All right, let's do another one here. We've got negative 3/4 x plus 1/2 y equal negative 1. All right, so we're going to have to add 3/4 x to both sides, right? So I'm going to have negative 3/4 x plus 3/4 x plus 1/2 y equal 3/4 x minus 1. All right, so These guys go away. That leaves me with 1/2 y equal 3/4 x minus 1. So what am I going to do to both sides? I'm going to have to multiply each side by 2, right? So that I can isolate this y. So when I multiply by 2, so I have 1/2 times 2y equal 3/4 times 2x minus 1 times 2. All right, so that gives me y equal 6/4, which reduces to 3/2, and then minus 2. All right, I've got my slope. My slope is 3/2, right? Up 3/2, and my y-intercept is 0, -2. And then I can take that and graph it. So just be careful. Don't let fractions kind of freak you out. So here's what I did. 3 times 2 is 6/4. Both of those can be divided by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. That's how I got that. And then I simply multiplied -1 times 2. So work with fractions. They're really easy to work with. And then once you can get it here, it's going to be really easy to graph it. So let's do that. Let's first write an equation, and then let's get that equation graphed once we know what the slope and the y-intercept are. So we'll do that first. So if we start out with an equation, -2x plus y equal 1, knowing that y equal mx plus b is what we're shooting for because m is the slope, b is the y-intercept. So this one looks pretty easy so far, right? We're just going to add 2x to both sides. When I do that, that means my y is by itself, and I've got 2x plus 1. All right, so I've got y equal 2x plus 1. So all I need to do here then is to go ahead and graph. So I'm going to get my line here. All right, of course we have the origin, and I'm going to first plot, so each of these is 1, 2, 3, 4, 5, so I'm just going to put that 1, 2, 3, etc., -1, -2, -3. We've got -1, -2, -3. So we're going up by 1 each time. And if we have to do a little bit more, we'll do a little bit more. So we know that our y-intercept is what? So let's first identify our slope here. Our slope is 2/1, right, or 2. But I always like to write it like this because that gives me a rise over run. And then my y-intercept is going to be 0, 1. All right, so I'm going to first plot my y-intercept. So I'm start at 0, and it's going to intercept right there on the y-axis. And then my slope is up to 1, 2 over 1. So I've got 2 points there that I can go ahead and graph through those 2 plotted points there. And that's what the graph of that line looks like. So I often take it just a little bit further so that everybody knows what the graph, that this line's equation is -2x. Sorry about that. Y equal 2x plus 1. So got our y-intercept. Then we use what we know about the slope to go up 2 over 1. That's our rise over run. And we got it. Let's do one more just to check ourselves. All right, so if we have an equation here, 4x minus 7y equal 14. All right, we've got to get it into y equal mx plus b. Why? Because m is the slope and b is the y-intercept. If I can get both of those, I'm golden because I can go there and graph it really nice and easy. All right, let's add 7y to both sides. I'm sorry. Let's subtract 4x from both sides. Thank you for catching that. So we've got 4x minus 4x minus 7y equal minus 4x plus 14, or negative 4x, right? All right, these guys are going away. That leaves me with negative 7y equal negative 4x plus 14. All right, so I'm going to divide both sides by, you got it, negative 7, right? And negative 7. All right, so we've got y, because these go away, equal positive 4/7 x. And then 14 divided by negative 7 is negative 2, so I'm going to say minus 2, right? So negative 7 goes into 14 two times, but it's a negative there, so it's going to be negative 2. So I've got a slope of 4/7, rise over run, up 4 to the right 7. By the way, if you got a negative there, you're going to go down and then to the right. So you're going to go down and to the right. Negative, the rise is a rise going down, okay? Or to the left. So we've got 4/7 is our slope, and our y-intercept is at 0, negative 2. All right, so we know that. So let's go grab our graph here, and each of those represents 1. So first and foremost, I'm going to graph 0, negative 2. So 0, negative 1, negative 2, right there. Now, if my slope is 4/7, I'm going to go up 4. There's no negative there, so up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Oh, almost ran out of space there. And then I'm going to get my line. It's going to go right through there, slightly off over there on the top right. But we got a line of a graph that represents y equal 4/7 x minus 2.